Hi, my name is Marit van Dijk, and I'm here today to talk to you about reading code. Just a quick check, who's a Java developer? So for those of you who are not, there will be Java code in this presentation. So if that offends you in any way, I don't want to waste your time. It's okay if you want to leave, but please don't put in the evaluation, there was Java code. So you have been warned. So as you know, as developers, we spend more time reading code than we do writing it. Reading code is part of many tasks, like when we have to add a feature or fix bugs or trying to understand the new system that we have to work on. When we're doing code reviews or learning about new technologies and reading books or blog posts or even watching videos, etc. A lot of this includes reading existing code and understanding that code to know where we need to make our changes. In fact, developers on average spend as much as 58% of their time trying to comprehend existing source code. This is a quote from a book by Feline Hermans. Feline is a professor of computer science education in the Netherlands. So her domain is literally how do we teach programming, how do we learn programming. She wrote a brilliant book, in my opinion, called The Programmer's Brain, with the subtitle, What Every Programmer Needs to Know About Cognition. I highly recommend this book. I don't get a commission, so... and we spend more time reading code than writing code, but we don't practice reading code explicitly. We learn programming by writing lots of code. We do code katas or maybe refactoring katas or other kind of code practices, but we don't practice reading code, even though we spend more time on that. Just to be clear, when we do talk about readability, we often talk about writing readable code. So we're still not talking about how do we read it, what helps us understand the code. So Feline is also a conference speaker, and in 2019 she spoke at a conference called Strange Loop, and her talk was called How to Teach Programming and Other Things. Again, that's her research domain. And in this talk, she mentions research from 1992, which is before I even learned programming. And in that research, they had a classroom of students learning programming. And they split the classroom in 3 groups. The first group would write code and read code. The second group would write code and read code with explanations on what particular choices were made in the code, why certain implementations or patterns were chosen, etc. And the third group would only read the code with the explanations and not write any code at all. And what they found was that actually the second and third group were better able to reproduce the programming concepts that they were learning than the first group that just wrote lots of code and read code without any explanation. So reading code with explanation also helps you better learn programming concepts. But still, we teach programming by writing lots of code. Interesting. So after Feline gave this talk, someone came up to her and said, but what if we practice reading code explicitly? And that's how Code Reading Club was born. So they started a club specifically for reading code. I'll share a link to the slides at the end, so all of the links in the slides you can find on my website. But they started a code reading club and they started doing exercises to explicitly, deliberately practice reading code. And I heard or read about that somewhere because I follow Feline. And I was like, that sounds really interesting. I want to do that. And I got really lucky because a friend of mine reached out and said, hey, we're starting this code reading club. Do you want to join? I'm like, yeah, I do. I love it when the universe aligns, right? That was about 2 years ago. We've been doing this club roughly every month, unless some of us travel, so I can't make it every month. And we have an hour and a half where we take a sample piece of code and apply exercises to that code. Let me tell you what that looks like. So we have a printed code sample. Coincidentally, finding a piece of code that is 1, maybe 2 pages that you can print out and still has something going on is harder than you'd think. But we have a club that is different people in different countries. So I'm in the Netherlands, Other people are in Germany, the UK, even in the US. We work in different roles, in different companies. We use different programming languages, and we take turns facilitating the sessions. So we each bring different pieces of code every time. So we have a printed sample of code. You can also do it online with an annotation tool, and then we apply structured exercises to that piece of code. And one of the things I like is you annotate the code. You get to use colored markers, and as adults, we don't get to play with colored markers enough. So this slide is the actual result of one of our code reading clubs. And I'll give you some examples of the exercises that we do. The first example is called First Glance, and that's literally what it is. You take 1 minute to look at the piece of code and write down what is the first thing that you notice about this piece of code and why. And what's interesting to me is that different people in the group with also different backgrounds, different roles, notice different things in the piece of code. Sometimes it will be, oh, this is a concept that I'm familiar with, so that gives me a hint of what this might be about. Or this is syntax that I have never seen, and I need to understand what that means before I can try to make sense of the rest of it. So that's really interesting. Next, we try to identify components and relationships, so variables, methods, instances, and how they're used throughout the code. Which is interesting because then you can think about how do I identify these in a different language? Does it use a familiar syntax, or is it different? We discuss what are the 5 most important lines in this piece of code, which is another really interesting exercise if you don't agree beforehand what most important means. So, like I said, we have people in the group with different roles. Some have, for example, a testing background, so they would be, these are the most important lines because something is going on here that needs a lot of test cases. Other people would be like, these are the most important lines because they help me understand what this code is about, and it might be the name of the file or the name of the class or a comment that gives a hint of what it's about. Other people might select, these are the most important lines because they determine the control flow of the code. So again, different perspectives, different most important lines. And what we also noticed in our club is that over time we converged on what the most important lines were. So when we first did this, we had wildly different results. And as we did it more and more, we kind of agreed on what most important meant. We identify the concepts in the code. Sometimes there were unfamiliar concepts, but usually someone in the group would be able to explain those things to the rest of the group. And it would always be a different person. So it's not like one person knows all the things. Together we know all the things. And in the end, we take a few minutes to write a summary of what we think the code is about and what does it do. And even though we didn't really look at the meaning of the code in the previous exercises, we look at the structure of the code, for example, we are usually able to approximate what the code does. So I really like doing these code reading clubs because I learned, obviously about reading code and strategies to approach that. If you're ever confronted with a piece of code that is super overwhelming and you have no idea where to even start, the first glance exercise is perfect. You have 1 minute. Just find something that you notice and that will give you a place to start. But also I really, really enjoyed learning about other people's perspectives and how they noticed completely different things about the code. Things that I thought, oh, that's super clear. Other people were like, what is going on? Or things that I kind of ignored as that's not as important to me to understand this code. Other people will be really fixated on, I need to understand this because otherwise I can't make sense of it. So I really liked having that empathy of different people noticing different things in the code. And also it helped me to make my own assumptions more explicit because I had to discuss it with other people. So if I would focus on one thing or ignore something else, I had to make that explicit. So it also helped me with my metacognition of how I try to make sense of the code. So I wrote a blog post about that, if you'd like to read it. And the thing that I like most about Code Reading Club is that we are reading the code not to judge the code, which is what we usually do, right? If you look at code that's written by someone else or, past you, who was also someone else because you learned new things in the meantime, usually we go like, that is not how I would write that today, right? From the giggling in the audience, I'm going to assume we're on the same page. So what I like about Code Reading Club is that you practice reading the code to understand it. And I think that that's a helpful mindset to have when working on code, to first think about, hey, what does this code do? Why is it the way that it is? Why is it the shape that it is? And have a little bit of empathy and understanding first before you start, okay, here's how I would change it to be the way that I would like it to be today. I mentioned Felina's book, and in her book, she discusses reasons why code might be confusing. Lack of knowledge, a lack of information, or a lack of processing power in the brain. These are tied to our cognitive processes. So knowledge is the information that we have stored in our long-term memory. The information that we have available is stored in our short-term memory, and how we process that is our working memory. So a lack of knowledge in understanding code might be related either to the programming domain, the language is unfamiliar, or the syntax is, or it uses programming constructs or algorithms that you don't know. Or it might be in the business domain, so domain concepts you're not familiar with, or business logic that you don't know yet. And we can deal with a lack of knowledge by creating a list of the things that we don't know and might want to research. And for some of those things, if it's knowledge that we need a lot, a particular business logic that our application deals with that is very central, or particular syntax that we use everywhere, it might be useful to actually memorize that stuff. I know that we can look it up every time, but that takes a little bit of time and away from your cognitive processes. So it's good to have the information that you need a lot actually stored in your long-term memory. A lack of information could be unknown details, so a library method that you don't know the exact implementation of, unfamiliar names, especially if it's a domain that is new to you. Code can be connected in unknown ways, or there can be simply too many things going on at once that you can't keep track of. We can deal with this by chunking. Who's ever heard that we can keep 7 plus or minus 2 things in our short-term memory? Some of you. Turns out it's actually less. It's more like 2 to 6 things, which means we need to use those slots wisely. So it can help to actually familiarize yourself with patterns that are common so that we can put information as a pattern into one chunk rather than all of the components of that pattern. So concepts and patterns can help you to keep more information in your short-term memory. A lack of processing power in the brain comes from too many processing steps or too many variables to keep track of. I'm sure you have a piece of code where it's like, I have no idea how to keep all of this in my head. Don't. You can deal with that by using memory aids like a dependency graph or a state table. So a dependency graph could look like this. If you print the code and you identify the variables and methods and then just connect them throughout the code to see how the control flow works, you can visualize that without having to keep it in your head. This is a piece of Erlang code that I literally took from the Code Reading Club website. I have no idea where it's from because I know some of you will be wondering. I got that question before. A state table could be if you have multiple variables that are changing. I deliberately put like a really basic nested loop here, but I'm sure you have examples that are more complicated, just to give you an idea of what that would look like. So you can trace the values and put them in a table. So Felina was writing another book called Code Reading in Practice. Unfortunately, she put that project on hold, but it was on the O'Reilly website for a while, and I read it, or at least what was there. And she talks about 4 dimensions of code reading in this book: structure, domain, concepts, and context. In terms of structure, we know that code isn't read linearly. We don't start at the beginning and read it all the way to the end. It isn't run linearly either. So we tend to scan code looking for the part that we need and then zone in on that and find the details that we need. The domain can deal with both the behavior and the data that it deals with. Concepts we discussed can be in the programming domain or the business domain. And then there's a lot of context to our application and potential history. Why was it built? How was it built? Under what circumstances was it built? Did we have the time to build a nice application, or was there a lot of pressure and did we have to cut corners? So then let's look at the practicality of reading code and exploring new code bases, and also how our IDE can help with that. So when you join a new team or a new organization, you'll have to familiarize yourself with an existing code base, usually. Sometimes we get to build from scratch, but a lot of the time we're working with existing code bases. And we'll have to figure out what that code does. And if we're lucky, we have a team that can help us get a bit of context. It's what we did at one of my teams in my previous job. When someone joined our team, we would give them an overview of each of our microservices and be like, this is, this service, this is what it's for, this is the place in the landscape. It's been around for years, we've been working on it, we work on this section a lot, we barely ever touch that section, kind of the Cliff's Notes of what to focus on and how to familiarize yourself with the application. Also the place in the landscape, what are the other teams that we work with, the other applications that we talk to. And that can be really useful for you to do if people are joining your team, or ask for if you are joining a new team. Obviously, after that, a good place to start is to actually check out the code and look at it. And then we can see how our IDE can help us. I'm going to use my favorite IDE for reasons. I do work for JetBrains, they do pay me. But I hope that even if you're not using IntelliJ IDEA, you'll find some useful approaches. That is at least my intention. So if we're looking at a new project, or a project that is new to us, some of you are Spring or Java developers, who uses Spring? Who's never heard of Spring? Spring Boot is a framework for Java applications. What language do you use? Like Aspire, maybe? I have no idea what .NET frameworks. Anyone? What is the .NET version? Yes, thank you, that's the one. See, it started with an A, that's all I got, sorry. Okay, so for the C# folks, the opening brackets are gonna be on the line where the method name is declared rather than the next one, and the interfaces don't start with I. Other than that, it will look familiar. So if you're looking at a new project, we can start by looking at the files and just see if we can get an idea of high level what the application is about. So I'm using the Spring Pet Clinic. Who's familiar with the Spring Pet Clinic? A few of you. Okay, so the Spring Pet Clinic is a Spring Boot demo application by the Spring team to show you how you could use Spring Boot. It's fairly small, so it's a good first, how to explore a project. So if we look at the code, we can look at the packages and see what kind of classes are there. And we see that some are in the business domain. It deals with owners and pets and vets. For the non-native English speakers, vets are pet doctors. So some are programming domain, some are business domain, and it gives us an idea of the type of entities that this application deals with. It's not too big, so I'm not as overwhelmed as I might be. I also highly recommend that we run the application. Oh, no, that is not it. Make sure that you can actually build the application before you make any changes, because otherwise, if it's broken after you make your changes, it's really frustrating to find out whether you broke it or it was already broken. Ask me how I know. So while it's running, Maven projects you can usually build with Maven Verify or Maven Clean Verify if you want to be extra sure and have Andres Almirai come yell at you. So in most of the teams I was on, we would have standard ways of building all of our applications. So see if you can build the application in whatever way you're used to. If not, go look in the README whether there's information on how to build the project. This is a demo application, again, by the Spring team, so obviously they have all of the information on how to build it, etc., in the README. And that seems kind of superfluous, but I have worked in teams where every application was built differently. Some were using Tomcat, some were using Jetty, some were still on Spring, some were already on Spring Boot, and literally every application was built differently. And then the READMEs would be like, this is the repo for this project. Thanks, super helpful, right? And I'm too old for that stuff. I can't remember how to build each and every project. So one of the first things I did is in every README, okay, this one, do it like this command, da-da-da-da-da-da. Anyway, so if your READMEs are like this example, please, for the love of code, add how to build the project, how to run the tests, etc. Thank you. So we can build the project, meaning that now we can make changes, and at least we know we have a running project. I also like to look at what kind of dependencies a project is using. That way I can have a look, is it using libraries that I'm already familiar with, or maybe some that I'm not familiar with? I can add those to my list of things that I might want to research. It can be helpful to actually run the project. Run the project, yes. And have it running locally. Now you know that you can run it locally, which is useful, so you can test your changes after you've made them. You test your changes, right? Okay. I don't know if that giggle means no, actually we know we should, but we don't, but I'll allow it. So, and also if we have our application running, then we can observe what it does. So, and coincidentally, puppy and kitten tags. So we can have our application running, we can kind of explore what it does. So we see that we can find owners, we can find veterinarians, and the Spring team has added a helpful error page so we can see what happens if our application throws an error. Which, if your application is running an error, you might have an AI assistant that you can use to explain that runtime error to you. We know that error messages are not all created equal, and some are more or less helpful. So that might be a way to familiarize yourself with that as well. Other things that we can use is we could generate diagrams. For example, we can generate a Java classes diagram to see what entities we're dealing with and how they are related. If you have a small-ish application, that will actually fit one page. If you have a really large application, I'm sure you've automatically generated diagrams that were like little tiny boxes that weren't very useful. There are different types of diagrams that you can generate. It can be helpful to, if you're visual like me, it can be helpful to visualize what your application looks like. However, Felina, in the book that she was writing, does recommend that you draw your own diagrams for two reasons. One, you can focus on the area that you're actually interested in related to the task that you're working on, but also you'll be able to retain that information better than looking at a diagram that was provided. By basically like working with the material and drawing your own diagram helps you reinforce that information. Now, this is a fairly small application. I feel like I have an idea of what it's about, and I feel fairly confident that I can make changes to it should I have to. But what if we have a project that is way bigger? So I'm using Cucumber JVM as an example. I worked on that in the past a little bit, but as you can see, it has many, many modules. It might be hard to know even where to start when you have to explore this application to work on it. I happen to know that most modules have a README to explain what they're about. There might be some terminology in there that you don't know, so you could add that to your list of stuff to research. But it would be good to know how these modules are related. So there are tools that can help you visualize that as well. Yes. You can, of course, look at all of the individual modules and figure out how they are all related. But there might be tools that can help you visualize that. So in this case, I'm using the dependency matrix. By the way, can you see this in the back, or should I zoom a little bit? Zoom, okay. Zoom a little bit, okay. So as you might be able to see, we have the same modules in the matrix that we have here in our project, but they are sorted differently. They are sorted according to usage. So the modules that are used by other modules are sorted towards the bottom, and the modules that are using them are sorted towards the top. And then the dependencies are marked in blue, as we can see in the legend here. So we can see a particular module uses another module however many times. And if we click them, we can also see the direction, which is explained in the legend here. So the green dependency or the green module uses the yellow module. And then we can click to see what uses what and give us an idea of how things are related. We can also visualize that in a diagram by looking at the project modules, but then we get only one half of the equation. So this module uses these other modules. And from that, we can piece together how everything is connected. So project structure, building and running the application, looking at the README, looking at the dependencies, and looking at diagrams can help us to get a broader picture of what the application is about. Outside of our IDE, we can look at the components and the relationships and dependencies between them, identify the concepts, maybe also the ones that we don't know and need to research, and gain context about the application, the history, where it's going, etc. It might also be useful to look at a slice of the application related to a specific use case, maybe. So for that, we need to find a starting point, which can be either generic, like a main method, or an endpoint to an application, but it can also be specific if it's related to a specific task, like where is this error message or exception thrown? Where is the logic or functionality that I need to debug or change? Obviously, our IDE can help us there because we can search for things. So for example, we can search for the main method. Which if you use Spring, you know that's where the Spring magic starts. So it's maybe not the best place to start for debugging unless you're trying to figure out how Spring works. But if you're using a different type of application, then the main method might be a good place to start to get an idea of the control flow of your application. If you're using any kind of CRUD or REST-ish application, it might be useful to look at endpoints. So see if you can get an entry point into your application and then trace it all the way down and back up again. So for example, here we can add a new owner and then save that in the repository. So we can trace it from the outside in and back up again. I sometimes draw or write little things on a piece of paper to note down the control flow for the thing that I'm looking at. I find that useful. It helps me also reinforce that information in my head by writing it down. Also, I'm old. I like writing stuff down. I don't know. So that's one way to do it. There are other ways that we can look at endpoints. So for example, I don't know if you're using Swagger. You could look at Swagger pages. You could look at the endpoints, the OpenAPI documentation. Stuff like that. You might also need to find where a particular error is thrown, so you can search for that in your code. And then you find the particular place in your code where an error is thrown, and then you can find the context of where that is in your project. So, you know, basically you are here in the code. From there, you might get a bit of context to see what package you're in or what module you're in, and you can trace it actually back out again. So that's more of a bottom-up than a top-down approach. So searching and navigating in your IDE can help you get a better picture of what your application is like, and you can apply that to a particular use case, so you can figure out for this slice of the application, how does that work, and build up your knowledge from there. And draw your own diagrams as related to the thing that you're working on. So finally, we might find a piece of code that we really need to understand. And then, of course, the structured exercises can help. I don't know if you've ever seen a piece of code that has been so overwhelming that you don't even know where to start. Now you have structured exercises, and you don't have to be overwhelmed anymore, because you'll always have something to do. But obviously, also your IDE can help you. Here I have a different example and a bunch of things that I want to show you. Let me fold them away for a second. So obviously, if you're reading code in the IDE, you have syntax highlighting, which you might not always have if you're reading blog posts or books. And the syntax highlighting will help you make sense of the code. If not, there are ways that you can pull up information in your IDE, like quick documentation, or your IDE might give you inlay hints about types, but if not, you might be able to pull up type information for expressions as well, or look at the code in your editor to give you a bit of information without having to navigate throughout the code and getting lost potentially. We use the structure of the code, like I mentioned before. We don't read code from start to finish. We look at the structure of the code, so white space can actually help you to make sense of the code, but also it can help to fold code away so that you can look at just the high-level structure of the code before being overwhelmed with details, and then you can still search the code for specific things, and relevant sections will, if I type it correctly, will expand based on the thing that you're looking for, and then you can expand those sections as needed. There are other ways to get an overview of your code, like a structure view that will basically do the same thing but in a separate pop-up. Or we just added this in the latest release, which came out this week, which is pretty cool. We have a new logical view on your Spring Boot applications. Actually, let me find a controller where we can see again also the endpoints. So that's a new logical view on your code. But we have the same physical view as well, but off to the side instead of a pop-up. So this can help you get an idea of the structure of the code. There might be other ways to do it as well. We might, of course, want to look at the behavior of our code. Hopefully you'll have tests again. And hopefully also your tests will, let me actually make sure that I have a breakpoint. One thing I forgot to tell you, so if you're typing code in the IDE, then it will auto-format the code for you. If it's not properly formatted, your IDE can, of course, reformat it, and there's linters and stuff that you can use. And again, we use the white space to scan the code, so having a bit of formatting actually helps make it easier to read. We'll want to look at the behavior of the code. So we can go to the tests, and hopefully the tests will have names that express the intended behavior of the code. Because if they fail in the future, if you write the tests, give the test names of the intended behavior, it helps you think about what the code should do. But B, if they ever fail in the future, it's helpful if they have a name that expresses what it should be doing, so that you don't have to figure out A, what this code should be doing, and whether B, my changes actually broke something, or maybe there's a use case that I forgot about and some behavior that I also need to change and some tests that I also need to update. And for me, this kind of goes without saying, but I have found code that had tests named test scenario 1, test scenario 2. I tweeted about that and some friends responded with, so are you now sad 1 or sad 2? I'm like, yes, I am. So, please don't do that. Please give your test names that express the intended behavior, because it will be very helpful if they fail in the future. It will save you time on analyzing what is wrong. So, breakpoint, yes, I do, okay. So obviously, if we want to make sure that, or if we want to verify our assumptions, we can run the code through the debugger. So if we run the code through the debugger, when it hits the breakpoint, it will stop and we can observe the state of our system. Who uses debuggers to make sense of their code? Good. Okay, I'm going to do like all of the stuff that you already know. But there's way more on debuggers, and please learn to use your debugger before you actually need it for an urgent production incident. So when we hit the breakpoint, we can see the state of our objects and variables and whatnot, either in the IDE or in the editor or in the debug window. We can see the call stack. We can also evaluate stuff, which can be fun. I find this super useful. You can evaluate an expression. Obviously, some of this information we already have in the window, but we can also write different expressions. And I sometimes use this if I'm trying to debug something and I'm not quite sure what the right solution is, and I can just try some stuff out here in the evaluate window, and then until I get the right thing, and then make the changes that I need. We can step into specific methods, or we can step over, and we can continue to run our application. But I find running stuff through the debugger really useful to make sure that how I think the code works is actually how the code works. And I know that we said that we would read code to understand it and not make any changes, but sometimes it can help to make some changes to the code and kind of play with it and refactor a little bit. We can change the order of things, for example, if we want the public and private methods sorted with the public on top and the private ones at the bottom. We can move them around, kind of play with it. We can, if we have really long methods, for example, we can extract methods and give them a meaningful name. That helps as well. So cancel, I can't type, cancel item. When we are playing with variables, we can either extract variables or inline them. So if we don't need a separate variable, we can inline the variable. Or if we want to give meaningful names, we can extract the variables again and give them meaningful names. We can rename things if we want. In this case, the name is good, but we can use renaming, refactoring, if we gain more understanding of the code and give it more meaningful names. I'm sure we've all seen single letter variables, apart from the classic for loop, where I is maybe a useful variable because of what we're used to. Don't do that. Give them meaningful names. We're not penalized for the number of characters that we're using. So sometimes it can help to break stuff up into smaller pieces and give it meaningful names. Extract a really long method in several steps, etc. But also just play with the code and do some refactoring, and then undo it at the end. It was only for you to play with it and understand the code. Especially if you have tests that will also test the code, then you can safely do your refactoring and make sure that you didn't break anything. At some point, it might help also to get a little bit of context of why is this code the way that it is. Sometimes you find code and I'm like, hey, that's not the way I remember it. Why was it changed? I like to do what I call a little bit of Git archaeology and find out, hey, when was this last changed and why? So we can look at the Git annotate and find out when the last change was made, go back to that commit, for example. This is my demo project. It was made by me, myself, and IEA. So then we can look at a particular commit and see what was changed there. In my previous company that I worked for, we would put the Jira tickets in the commit message so that we could go to, I see people nodding, you do that too. So you can go to Jira to find more information about that particular user story, which can be useful. Also, if you're using an AI assistant that has this functionality, you might be able to ask AI assistant to generate a summary of what happened in a particular commit. And or you can look at the diff, of course. But if the diff is very large, then getting a summary might be useful. And obviously, we can look at the diff to see what actually changed in the code. So all of that can help us understand why the code is the way that it is right now. Let me close that again. There are other things that an AI assistant, again, sorry, JetBrains do pay me, can do for you, like explaining code to you. Actually, these are the things that I like the most about using AI assistant. I know that I can get it to write code for me, but that's the part I actually like. I really, really like the functionality that helps me work with existing code. So, for example, we have the option to have it explain code to us, which will start a new chat where it explains the code. It can be a little verbose, sometimes more verbose than Java, but it can be useful, and you can also add prompts or refine prompts. We just added a new feature where you can give it like a general prompt, so you can tell it to be more concise or change it to whatever your preferred language. I'm sure most of us have English as a second or possibly third language. So I find explain code really useful. Also, who likes regex? God, there's always some of you. So for the rest of us, let me show you some useful things. There is also explain regex, which is nice if you have to work with those other people who like regex. So there's that. That's an AI assistant feature. We also have a check regex, which will tell us whether a particular string does or doesn't match the regex. Okay, someone who knows regex, what would be a string that matches this? Okay, there you go. So now, you know, it needs this many numbers, then it's valid. If we put any letters, then it's not valid. So that can be super useful as well. Who likes cron expressions? No one. Ah, thanks, Scott. So if you don't like cron expressions, let me find the... We have inlay hints that explain the cron expression, but if that's not enough, AI Assistant can do that for you too. So, you know, these are the ways that AI assistants are useful, in my opinion. So lots of ways that your IDE and AI assistant can help you understand existing code. So we can look at the structure, we can get lots of hints from our IDEs, that's something that they should be good at. We can look at the tests and debugging. You can refactor for understanding, but throw that away. That is just for you to play with the code. If it's important refactoring, then you can do it later, as discussed with your team. Look at the context. Why is the code the way that it was? When was it last changed? What was the reason? And see if an AI assistant can help you understand some of the code. Yeah, just about regex. I saw this tweet just before I did this talk the last time. The plural of regex, for those of you who like regex, is regrets, just so you know. So other strategies for dealing with code, structured exercises are really helpful. memory aids, like drawing stuff out, visualizing it, gaining context of why the code is the way it is, have a little bit of understanding. I'm sure the people who wrote the code didn't mean to write what you now perceive to be bad code with everything that you know now. We all know that we are under pressure, we need to cut corners, etc. So what might be next? If you are interested in doing a code reading club, they have a website, they have a Discord where you can ask them questions, and they have some resources on GitHub where they have three, maybe 4 sessions all planned out for you with code samples, exercises that you can do to do the code reading club, that you can apply to that code, notes for a facilitator. If you've never facilitated these kinds of things before, how can you facilitate that club with either your team or like-minded colleagues or friends? And The Programmer's Brain by Feline, which I would highly recommend anyway, also has lots of exercises that also you can do by yourself, that you can apply to your code base if you can't find people to do a code reading club with you, or if you don't want to do it in a group setting. Obviously, let your tools help you, but don't forget to use your brain and work with your brain and your cognitive processes. And you can find the slides on my website and lots of links to related materials, everything that I mentioned in this talk. I haven't been able to upload today's slides, but this is not the first time I've done this talk, so you can find the slides for previous versions. I'm here all day if you have any questions. I'm free to take questions now. I don't know if there's any online questions. Otherwise, I'll be around all day. You can find me.